Good morning, everyone. So we'll try to solve a similar problem that we have solved in the previous class. So thus, I think it's not much different. I've added one more point load onto this. So very similar to the previous class, we'll try to convert this into a free body diagram. So I'll write a free body diagram here. Free body diagram. So free body diagram has to be drawn like this. So free body diagram refers to only forces acting on it and there are no supports shown. So what these two supports are actually doing is they are actually trying to support with a vertical force like this. So I'm now trying to do this and then I will try to add the loads. Loads one at 2 meters and one at 1 meter. 1 meter. So this load was 5 kilonewton. So this load was 5 kilonewton. I will redraw this. So 2 kilonewton. So this is 2 meters. 1 meter. 1 meter. 1 meter. I'm recording. Okay. Now, once you have done this, of course, you need to reserve this place below. For SFD BMD. Okay, and then you are supposed to find the reaction at all these points. So let us name these points as A, B, C, D and D. Okay, so we'll call this load taken by the left side support as RA, which is not known to me. Load that is taken by the right side support as RE. So we need to find this too. So for that, yesterday I said you take the moments about one of the supports. So we prefer to take the left side support, sigma ME is equal to 0. So use this formula. So that means if you take the moments about, A, it is 0. So taking the moments about A, so about A, now this whole thing, about this, these forces are trying to go downwards. So there are 3 downward forces. So one is plus 5 kilonewton into 2 meters. So then again there is 4 kilonewton into 3 meters and plus 2 kilonewton into 4 meters and there is one force which is going upwards. So RE, so that is not known to me. RE into how many meters? 5 meters, which is equal to 0. So now you find out RE. What is the value of RE? 6. So you get it as 6 kilonewton. So once you have got 6 kilonewton, then you can say that upward forces, sum of forces equal to 0, which means that downward forces are equal to upward forces. Okay, so downward forces are, so upward forces are RE plus RA, which is equal to downward forces are 5 kilonewton plus 4 kilonewton plus 2 kilonewton. So what is RA? 5 kilonewton. So RA is 5 kilonewton. So once you have got this, so then you can replace this. RA as 5 kilonewton, RA as 6 kilonewton. Then you can start drawing SFD and BMD. So for SFD, you can write this as SFD here. So that means whatever you are drawing here, it is the variation of shear force along the length of the beam. What I am drawing is the 0 line. So that means if I actually locate any point on this, that means the shear force at that point is 0. This is actually 0 line shear force. Okay. Now what is the convention that we explained yesterday? That means if it is the beam, if it is a section that you have considered, now we keep considering the sections and trying to find the shear force. Shear force at any point is the sum of the forces either on the left side or right side, and the convention is, what is the convention? Anything which goes down is positive. Okay, that's on the right side. Anything on the left hand side going up is positive. So these are actually positive. Ulta of this is the negative. Okay, now I start with this section here. Now imagine this beam has got extended. So suppose if I see here, there are no forces here, it is 0. Even now there are no forces on to the right side, it is 0. Even when I come to this point here, there are no forces on to the right side. That means even at this point, the shear force on to the right side is 0. And when I just move across this point force Re, so I find a force which is going upwards, whose magnitude is 6 kilonewton. Now as per the convention, going up on the right hand side is negative. So it goes from 0 to minus 6. So I don't write minus 6 here because below 0 is minus. Above 0 is plus. So it is actually going upwards is minus. So I have drawn it below. As I actually move the section like this, you see only a 6 kilonewton here. So that means this 6 kilonewton will continue until this point. When I cross this point, one is going downwards. So that means this becomes plus 2 minus 6. How much it is? Minus 4. It drops to minus 4 now. It will keep going as minus 4 until this point, until the next point. Again when I add, when I go here. So then what happens? So plus 4, plus 2, minus 6. So what will be the value? 0. Here it is 4 kilonewton. Here also it is 4 kilonewton. From 4 kilonewton it drops to 0 kilonewton. Now again you see that. Now as you actually move to the right side, it will be like plus 4, plus 2, minus 6, it will be 0 only. Now this line will continue here. It is continuing here like this, along the 0 line, it is continuing here. And then again, when you cross this one more point, then it is plus 5, plus 4. So 9 plus 2, 11. 11 minus 6, it is plus 5. So it goes to plus 5 here. So you can see 6 is so much. So 5 should be slightly more than and slightly less than 6. You don't have to measure it exactly. So it is 5 kilonewton. So some people don't like to see all this. So you could have even done this way. So that means you can check some of the loads on the left hand side here. Now as per the convention, anything which is going upwards on the left hand side is positive. If you see like this, so going downwards is negative, minus 5 and plus 5, it is 0. Now when you cross this point, then what is the value? It is plus 5. So now up to this point it is 0. And when you cross this point, it is plus 5. So it will remain plus 5. You can actually find out either ways, right or left side. So you are keeping like this until this point, you will only see plus 5. And again when you cross this point, plus 5 and minus 5 cancels out. If you actually imagine that the beam continues, any forces on the beam across this support, it is 0. So it actually drops from plus 5 kilonewton to 0. And it is the variation here. You see that the variation is like this, which means that you have got the 5 kilonewton shear force here, 6 kilonewton shear force here, and at some point it is 0 kilonewton here. So there are no shear forces acting at this point, and here you will see the highest amount of shear force. Now you have got the shear force diagram drawn. So once you are drawn, then you need to draw bending moment diagram. Bending moment diagram has to be drawn. Again, you need to draw the 0 line. So usually students will have a doubt whether to draw this line very close to this or should I draw here. Usually what happens is, when you have supports like this beam would actually bend like this. When there is a sagging, then this bending moment diagram will come positive here, like this. It will come positive, something like this here. So when it is hogging, suppose if it hogs like this, it will come below the line. So that means you need the 0 line slightly below so that you can draw the diagram here. So usually most of the cases beams will have sagging, but in only some cases where you got loads across this point, if you apply a load here, then it starts to hog. Only in those cases it is hogging. So most of the cases you need to draw the 0 line slightly below so that you can accommodate this diagram. So I'm now redrawing this 0 line, giving some gap so that you can draw it. Is it visible in the video? Is this line visible in the video? Yes, sir. So I'm extending these lines here. So drawing this 0 line here. So these are the points A, B, C, D, E, and along these points I want to know the bending moment. Bending moment is what? Basically force into distance. So force into distance, and suppose if it is the beam and it is the section considered, any force going upwards at a distance d. Okay, the formula for bending moment is F into d, and anything which is going upwards either on right side or left side, both are positive, because this will create sagging. So according to this, I again start using this book because this looks better. So I am now saying whether there are any forces onto the right side. No forces, no moments. When I come to this point, are there any forces onto the right side? No forces, no distance, no moments. So here it will be 0 kilonewton meter. Why? Because force is kilonewtons, distance is meters. So moment is kilonewton meter. Now when I actually start moving this way here, I got a load here. I got a force which is 6 kilonewton, and this distance d is increasing. It will keep increasing up to a point here. And what is this distance basically? This is 1 meter. So you will have, suppose if I am now here, suppose if I am here, you can say that the force is 6 kilonewton. Now as per the convention, it is positive. It's positive. 6 kilonewton positive multiplied by 1, it becomes 6 kilonewton meter. And it is linear because it is varying with respect to distance. More the distance, more the value. Okay, it is depending on just one value, one parameter. So it is linear. It goes from 0 to 6 here. So I draw a line, I mark it as 6 kilonewton meter. Okay, and then again I start moving here. Okay, I start moving. As I start moving, I will get one more point here. So when I go to this point is C. Bending moment at C. Bending moment at C, okay, I'll write here because earlier it was just easy because there's only one force. I'm writing here bending moment at C. Bending moment at C. Bending moment at C is, so the value of, so this value 6 kilonewton. 6 kilonewton into 1 meter, that was positive, but this is going downwards now. So it has to be taken as minus 2 kilonewton meter into what is the distance? Nice. Am I right? I am taking the moment at this point. I am writing here 1 meter. Is it right? I should write it as 2 meters. So it is the reason why you need to be alert, because you are taking the moment here and you want this force 6 kilonewton. What is the distance? 2 meters. And this is at 1 meter. So minus 2 into 1. So minus 2 into 1. What is the answer? So 12 minus 2. So plus 10 kilonewton meter. So plus 10 kilonewton meter. It varies from 6 to 10. So 6 is this much, 10 is this much. So I write it as 10 kilonewton meter and draw a line. So now the slope of the line will change because suppose if it had continued, it would have gone to 12. For 1 meter it is 6, for 2 meters it would have gone to 12. So now the slope has slightly changed here. So don't draw a straight line. Don't draw a continuous line. So the slope has changed here. Okay. Again, you can actually find out bending moment at B. Bending moment at B. Now, bending moment at B means I need to take 1, 2, 3, 4. 1, 2, 3. So instead of doing that, you can actually check. So you can actually check the bending moment onto the left hand side. It will be easy for you. So what is the convention? Anything on the left hand side going up is positive. So 5 kilonewton into how much? 2. So bending moment at B. Bending moment at B is how much? Plus 5 kilonewton into 2 meters, that is plus 10 kilonewton meter. So here also this is 0. Sorry, here also this is plus 10 kilonewton meter. Okay. And here you will see that here again, if you are saying here there are no forces, no distance, so it is 0 here. So here it is 0 kilonewton meter. So what you can do is here you can connect this as straight line here. From here to here, you can connect this as straight line. Sorry, it has to be at the same height. Sorry guys, this has to be at the same height here. This line has to be corrected. So you draw this. Okay. Now once you have done this, then you can ask this line. So usually so you understand that whenever you got a positive bending moment, so that means throughout you will have the beam to be sagging here, and you got a constant value of bending moment, so that means between this point it will be a curvature, exact curvature, and here very close to the end, the bending moment is almost zero, which means that this would almost become straight here. Now this line, this beam would be always straight. So more and more bending moment, guys, very similar to your scale. If you try to bend more, suppose if you apply more moment, then the scale bends by more curvature. In the same way, if you are applying more bending moment, so that means the beam bends more. Now the beam will have ulta I said, it will actually have less curvature, larger curvature. Okay, I don't know how to say it. So you'll have basically shorter radius of curvature here. You'll have a larger radius of curvature here. So when you've got less bending, so something like this, it will bend more. So you can say that there are more chances of failure between B and C by bending, but shear force there is very less chance of failure here. So something like this. So suppose if this problem is given for 10 marks, so 20 marks is reserved for finding out RA and RE, and 40% is reserved for SFD and 40% reserved for bending moment. Okay.